Hi folks, how are you? Sorry about the beginning to this video. There's a bit of a slight issue. For whatever reason, I was trying to use Teams to record this. So yeah, there are some slight visual issues. As I alluded to in the video, I was in hospital over the weekend, and I'm a wee bit off. So there have been some issues, but I wanted to get these out because obviously I haven't got anything out at this stage. And I was like, you know what, it's better late than never. So templates will be out today. At this stage, it's too late Sunday evening for me to be doing anything else. So what I'll be doing is I'll be looking into recursion, getting stuff for that done at some stage tomorrow evening, and then binary trees maybe Tuesday evening to get them up all hopefully by Thursday maybe. I'll try and work out how to use actual software to record it rather than using Microsoft Teams. So yeah, the beginning to the video is a little bit weird because it cut off my beginning audio. So this is essentially my introduction. Hi, I hope all's well. So yeah, thanks for tuning in. They're going to be very laid back. They're going to maybe approach things from a simpler point of view. I obviously do hope that people ask questions, um, but these aren't really meant to be viewed in place of your lectures. These are meant to give you a sort of a maybe an easier way to understand what can sometimes be quite complicated topics. So in our first case, we're talking here about templates, but later on we'll be talking about fun things like recursion, binary trees, and all of that really fun stuff that people love. So we're starting off with templates. Well, what actually is a template? So a template function is essentially it's a function that rather than you specifying what data type, you can set whatever types you or sorry whatever variables you want. So you might have an a and a b, and rather than returning specifically an integer, you might return a or b, depending on what function it is you're doing. So to give you an example of where this might be very useful is if we start off, and this isn't going to be very theory heavy, so a lot of these will be just in Visual Studio. We can see here if I have an int find max, and I'm going to take in an integer a and an integer b, and all I'm going to do is I'm going to say if a is greater than b, return a, else return b. And this is, a very simple function. So if we do int main and then give it a few variables, we can see here that int a is equal to 10, int b is equal to 20, and int c is equal to find max a, b. And the max value is this here. And if I run this code, we should hopefully see that in fact 20 is greater than 10, which we would like to think so. But obviously in this case, if I wanted to give this, for argument's sake, 10.5 or 10.20.5 and do the exact same thing, we can see here it will still return 20, but that's not the correct answer. And if even we wanted to use completely different, sorry, the reason that's not is, so if I do float a is equal to 10.5 and float b is equal to 20.5 and float c is equal to find max function. There we go. We should now see that this will still give us 20 here, but obviously, yeah, as we said, that isn't the correct answer. And if we use, I don't know, car a is equal to a and car b is equal to b, we just say car c is equal to find max. We should see, yeah, that there is actually a build error here, and you can see this isn't what we want at all. So rather than actually using specifically specifying a type here, I get rid of all of these, put them back to ints for the minute. Get rid of these here. We should obviously see that would work. But if we wanted to have a function that, we could in theory be taking different types. So for argument's sake, if you have a stack or a queue or some other form of data structure, it might be handy to have a function that pops, no matter what type of data type you have, especially if it's going to be one that, requires different data types. So in this case, the way that you would describe this is you go template, and then as we can see here, I very handily have GitHub um, doing, some of it for me, but I'll try my best to put in some stuff just to make it appear as if I'm doing my job correctly. Um, and we can go here and, oops, I've put in TT there. If A is greater than B, return A, else return B. And obviously in this case, we're going to get, if we can see here, if I run this, we're going to get that 20 is still greater than 10, right? But if I now want to test a different type, if I now wanted to test um, floating number D is equal to 10.5 and floating number E is equal to 20.5 and floating number F is equal to the find max of these, and then do F, we should now see that this will return 20.5 rather than 20. And even if we do this again and do car G is equal to A, car H is equal to B, car um what comes next, I'm just going to throw in Y here just because it's very late and I'm not able to think properly. We can see here that I have G, H, and Y, and if I type in Y here, we should see that, yeah, B is greater than A. And I'm going to assume that that's based on the ASCII value, which still works out to be true. So we can see here, this is a very simple example. So this is great and all, but like, how does this actually, help in terms of giving us something concrete for going forward with what will you actually do in terms of C++? And that's where we're going to start to move into more things like bubble sort functions. I don't really want to be covering things that could potentially be covered in practicals, so I'm sort of trying to come up with my own wee samples here. So if I do test2, and again, I'm going to include the IO stream. I do template cdaisy's type name t, and I'm going to do void bubble sort. Um, and as we can see here, we have a type of array and an integer n, and we're doing for int I is equal to 0, I is less than n minus 1, I plus plus, for int j is equal to 0, j minus 1, or j minus n minus I minus 1, j plus plus, if our index at j is greater than the index at j plus 1, we then say, well, um, our temporary value here is equal to array at the index j, and array at the index j is equal to array at the index of j plus 1, and array j plus 1 is equal to temp. And we might want to have another wee function that will maybe print this off for us. So if I do this here and do void print array, and we can see here this is going to give me a lovely little array here that will just go through the index and print this out. And obviously these aren't specific to any data type. So for argument's sake, you might have integers, and you might have yourself some characters, or you might have yourself some floating point numbers, or doubles in fact. So if we do an integer main here, and I'm going to be honest, I prefer to have them down here. Maybe that's bad practice, but that's just the way that I'm wired. And we can have here, oopsie daisies, an array, and we'll say 10, 20, 5, 99, 17, and 3 or 2, sorry. I feel a bit like I'm doing the lottery numbers there, but these are these are how that works. And then we do int int size is equal to the size of the array over the size of the array at index value 0. And we can do the same thing here for some values that are the same, but obviously with rather than rather than having integers, we're using doubles in that case. And we want to sort this out. So what we might want to do is we might want to do cout. Oops. I have to specify that that's standard output for the minute. Standard output cout before sorting. And then I can call print array and of int size. And then I might want to say standard out after sorting, and then I can bubble sort, and then I can print that again, and then I can do the exact same thing for the next values. Oops, we daisies. There we go. And sorry, I have to return 0 here. And we should see now if I run this. Oh no, there were build errors. The system cannot find the file specified. I have been getting these errors on my machine at home, which is a bit weird. So what I might do is I might just try and copy that into test one and see if that works. If I can maybe remove this and delete it. And there we go. We can see there that before sorting we have 10, 20, 5, 99, 17, 2, and after sorting we have 2, 5, 10, 17, 20, 99. And then in this case it's the exact same. And even if we wanted to go one step further just to make sure that just to make sure that our thinking is entirely correct, we might want to do car array, and we might want to have some of these values being weird, so like Z, U, C, A, B, D, or F. And then we're going to have our car size is equal to this, and then we're going to do the exact same thing here, but for this array. So rather than array 2, it's array 3, and array 3, and array 3. Just to show you that this really can work for any data type. Oopsie daisies, I've gotten rid of that. So you can see here A, B, C, F, U, Z, which is what we like to see. But again, bubble sort is, it's one of these things that I'm sure at this stage you're very aware about. Templates are also, they're not just for functions, they are also for classes. And that's something that you will cover in your classes. So class templates are also possible in much the same way that function templates are. So when you do this, you create a class that defines all the algorithms used by that class. However, the actual type of the data being manipulated will be specified as a parameter when objects of that class are created. Um, so if you think about it like this, um, if you have, for example, you have some class that is for a stack or a queue, it doesn't really matter which type you have. So I'm actually going to do a wee stack sample here. So what I'll do is I'll do include IOStream And I will do another wee template of type name T, and I'm going to say we have this class called stack. We're going to have some private variables just to make things interesting. So we're going to have a pointer. Oopsie daisies. I'm not going to call this data. I'm going to call this R because I'm a pirate. And what I can do is I can make a wee comment just to say this is the pointer to the array. And then say, rather than having top, I really want or so rather than having size, I want to have the top, which is the index of the top element. And then capacity is still the capacity, so the maximum capacity of the stack. And then publicly, what we probably want to have is, and I also probably don't, no, I think that's fine where that is in terms of the indexing templating, I guess. So publicly, we might want to have is, I don't want that to be created for me, preferably. Um, I want to have a constructor, so I want to have a stack. Ah. And this stack is going to have an argument which is just an integer of size. And within this, we're going to have the R is equal to new T size. The capacity is equal to size. And the top is equal to -1. So we have some pointer array which is pointing to some array. We don't really know the type yet. The capacity is equal to the size, and top is equal to -1. And that's our constructor. And then if you're following good practice, yes, there we go, we will have a destructor, obviously to free up the memory, which is just delete R. Um, and then what we're going to want to have is we're going to want to have some functions like push. So in this case, I'm going to say T, so some element. I'll use actual terminology rather than variable names, although whenever it comes to your actual practicals and tests, you might want to use X's and Y's rather than element, because obviously you're going to have maybe different elements. So I'm going to say, um, yeah, if um, is, oopsie daisies, is full, and then is full, we're going to describe that later. But just take this is to say, um, if the stack is full, and that's going to be a function, we're going to say, we're going to output to say, uh-oh, we have the stack is full. We don't want the stack to be full, preferably. Um, and you know, you can make this sort of as nice as you want. Uh, please don't push. Um, oopsie daisies, you don't put a colon there. Why is that not working? Oh, I just haven't had enough of them. So that is stack is getting closed there. Delete stack is getting closed there. This is maybe it just doesn't like me today. What's wrong? Add this at the end of the previous token. There we go. Now what's wrong with you? It wants one of these here. I'm gonna be honest, I don't actually know why this is annoyed, but we'll push on anyway. Um, and then we're gonna have, we're gonna have a pop function. Um, and within our pop function, we're obviously gonna say if, and in the same way, if the stack is full, we're gonna have an is empty function that we will define later on. So if it's empty, we're going to again we're going to do like a standard out. Oops, C out. And we're going to do stack is empty, please don't pop. And we're just going to return whatever type we have. And that can go out there. Else, you know what? You actually are allowed to pop. So you can return R and then top minus minus. Um, and then just to make sure that we're doing this for completion, we might want to have another function called peak just to see what's actually at the top. Because this is actually quite useful because if you think about it, there's going to be times where you're going to have a massive stack. And in this case, we can't just, I'll fill this in automatically. This is like a head, do you know whenever you're using Bash script or you're using, terminals, and you're doing cat and you're actually printing everything out, and that sometimes not very useful. Sometimes it's easier just to read the head because then you can get an idea of actually what's going on within the data. Um, and then after that, we can do just a few, yeah, is empty, is full, um, and then we're going to have an int, which is size, and that's just going to return top plus one. And then we're going to have our main function. So I think we can do the printing in the actual main function. So we have our int main, and just to make sure that we're going through everything step by step, I'm actually going to type this stuff out um, rather than doing all of this. So to start off, we're going to say, yeah, we're going to have a stack. We're going to say that the stack is an integer, and it's going to be our int stack. It's going to be size 5. So we have 5 values to play around with. So what we might want to do is we might want to push 1, 2, 3, 4, 5. And we can do top element is whatever. Um, stack size is whatever. Um, we can actually try and actually, hold on. This is good. This is always good to do, is to check to see if your code actually does handle these errors. What will actually happen if we try and push one that's too big? Um, and then we might want to do int stack dot pop. And then we should be able to see that. Hold on, sorry. Standard out. I don't want to take out the whole thing. C out. And then popped element. And then whatever we're popping, and then we can do standard end line semicolon. And why does that not want to work? Expected and expression. That's because I have a semicolon here. Namespace is not allowed. What have I done here? Standard. There we go. And we can do, yeah, like the stack size is now, or the maybe new top component. And then we'll do peak. And this should be, sorry, pop. Um, and then what we might want to do is we might want to do the exact same thing, but for type double. And I'll not go into the hassle of using characters or anything else. I hope you can trust me at this stage to say, and we'll maybe do less here, that if it works for your functions, it'll work for this here. So, but I would encourage you to mess around with this as much as possible and just try different things out because that's how you get to know these things really is actually just by sitting down, doing the practicals and messing around with things. So that's everything going. And now I sort of just hope that this works. So we have our lovely integer stack here. We're pushing on 5 values. The top element is, and then we check to see what the top element is. We check to see what the size is. We pop an element. So let's go. Let's start without debugging. Where build errors. What's going on? Oh, that's interesting. Where have I done C out without line 40? Undeclared identifier. C out identity not found. Hmm, that's an interesting one. I've definitely done this correctly. I mean, we can remove these if it doesn't like them, we can remove them for the minute just to make sure that everything else is working. So the top element is 5, which is what we expect. Um, and then our stack size is 5. Stack is full. Please don't push. Popped element 5. And then obviously once we get rid of the 5, then that means that the next top element is 4. And then with our double stack, our top element is 3.3. So I hope that this has been helpful. Templates are one of these things that sound scary, and maybe it's not something that there's a lot of resources online about. It's something that is covered well within this module, and it's something that is actually very useful, especially in an exam where maybe you don't have a lot of time. It's handy to be able to, well, actually, I don't need to worry about a million different types. You can just have a template that'll do things for you. So yeah, thanks for watching. Obviously, if you have any questions, please don't be afraid to ask them. Um, yeah, I hope this has been useful. Thank you very much.